All right, how's everybody doing today? We are going to take a look at the second example in our solving trig equations by taking square roots. So first, let's go ahead and just recap a little bit of review of solving regular algebra equations by taking square roots. So that looked like this. We did this in example 1, so you can refer to that video. But what I want to key on here is the right side where we have 4 plus 2x squared equals 5x squared. So as usual, you're going to go ahead and subtract 4 from both sides, or move the 2x squared over on both sides. That'll give you 4 equals 3x squared, dividing by 3, then taking the square root. And this is where you have to be really super careful, is on that step where you take the square root. Do not forget the plus or minus when you do that. Now, we'll simplify the numerator, and now the square root of 4 is just 2, and then the square root of 3, we'll just leave that as square root of 3. And of course, because you know that we can't have a square root on the bottom, you'd rationalize to come up with our final value of plus or minus 2 squared root of 3 over 3 for the value of x. So that's just a quick recap of solving algebra equations by taking square roots. Now let's take a look at our second example of solving square roots for trig equations. So similarly, we're going to want to group our like terms together. So here, if you notice, we've got a 2 cosecant squared and a 5 cosecant squared. And both of those, you notice, have exponents of 2. So we're going to want to get them together on the same side. So we will move the 2 cosecant squared over by subtracting that on both sides. And that'll give us 3 cosecant squared of theta on that side. Again, we want to isolate the cosecant squared, divide both sides by 3. So you're going to get 4/3 is going to be cosecant squared of theta. Now this is where, again, be careful, error alert, do not forget the plus or minus around the square root of 4/3. And that's going to be whatever cosecant of theta is. Now before we get into this, what I want you to do, we'll just simplify that a little bit. And we're going to have plus or minus 2 over square root of 3 equals cosecant of theta. Now, unlike my other algebra problem where I went through and rationalized, when I look at the trig function on the right, it's not sine or cosine or tangent. So I always want to get the trig function to be one of those three, sine, cos, or tan, because that's going to make it a little bit easier to find in a unit circle than because 2 square roots of 3 over 3 is not on there. So I don't really want to look at that. I want to kind of find a sine value, cosine, or tangent value that would be a little bit easier. So to do that, I have to remember that the reciprocal of cosecant, the reciprocal function that goes with that, and I always remember like s's and c's go together, it starts with an s, and that's going to go with cosecant. So the reciprocal of cosecant is sine. So I'm just going to take the reciprocal function and write that in place of cosecant. Now on the other side, I'm going to do the same thing. I'm going to just take the reciprocal of that. So I'm going to do plus or minus again. Don't forget that. And then you have square root of 3 over 2. This makes it easier to find on the unit circle, because when I do that, I have to say, all right, where is sine plus or minus square root of 3 over 2? And I know the unit circle that the sine represents the y value. So that is going to occur at this spot right here at pi over 3. That's where my y value is plus or minus is square root of 3 over 2. And then I'm going to have it again over here at 2 pi over 3. So that's going to be another square root of 3 over 2 for the y value. Now, similarly, if I go down in quadrant 3, my y values in both quadrant 3 and 4 are negative, but I also want the negative square root of 3 over 2. So be careful. Make sure you get the y value, not the x value, because that's a common mistake on that. So one would occur at 4 pi over 3, and then, of course, the other one is going to occur right here at 5 pi over 3. So those would be my 4 trig values between 0 and 2 pi, where that would be a solution to this equation. So when we're done, the way that you write your answer, would be like this. Theta equals, and then you can just start going around. So you can do pi over 3, and then 2 pi over 3. And then next we have 4 pi over 3, and lastly we've got 5 pi over 3. So these 4 values would be my solution to the equation 4 plus 2 cosecant squared theta equals 5 cosecant squared theta. Now we're going to check this, of course, using Desmos, so you can use graphing calculator, and I'm going to show you how to get that set up on Desmos. Now in Desmos, remember the first thing you're going to want to do is whatever's on the left side, you're going to put that y equals, you're going to put that in one equation, and then the right side of the equation, you're going to put that in another line in Desmos. Now what's going to make this one a little bit different, I want you to notice your x-axis. We're still going to have a step size of pi over 2, but this time, just because that way it'll be a little bit easier to see everything, we won't have to zoom in and out as much, I want you to have your x and y axis kind of match mine, where we go from negative pi to 4 pi for the x-axis, and the y-axis is going to go from negative 1 to 11. So go ahead and get that set up, hit pause, and then come on back, and let's just start playing. All right, so here we are, in our Desmos screen and everything, and you can see these two different graphs here, and of course, one of them is going to be our 4 plus 2 cosecant squared, and the other one is going to be 5 cosecant squared of x, and those are both, again, just use x for theta. Now, when we take a look at these, let me get this out of the way. I'm going from 0 to 2 pi, so I only want to stop, right here at 2 pi. I don't want to look at anything beyond that. So actually here, we could actually do this if we wanted to. We could just put another line in there and just say x equals 2 pi, oops, not minus, x equals 2 pi. And then we're going to see, that dividing line right there. So anything that's on the left side of it, we would be good at. And the other one, we want x equals 0. And we're going to make that, our other kind of boundary right there. With that. So anything that's within this window, that's where we want to look for solutions. So one of them I can see is right here at pi over 3. I got another one at 2 pi over 3, and then 4 pi over 3, and then over here at 5 pi over 3. So those are the 4 answers, the 4 solutions that we came up with, which is pretty cool. Now there's an infinite number of solutions, and we'll get into that in another video later on. But you can see I've got some negative values over here. So I have negative pi over 3 as a solution, negative 2 pi over 3. And I could keep going and, clicking out all the gray dots here where they intersect. 7 pi over 3, as well as 8 pi over 3. And then we got to, we'll just kind of keep going and keep going and keep going. It'll go on forever. And that's so, but we're only looking from 0 to 2 pi. So the only ones I would worry about would be these guys right in here. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And those are the 4 values that we got when we solved this algebraically. So that's pretty cool. So anyway, that's it for this video. Thank you guys for watching, and I'll catch you later. Peace out.